All right, here's the last section in our unit. We're going to learn about angle pair relationships. Now, some of these words, some of these angle relationships you have heard before, and some will be new. You've seen geometry a little bit before. So we're going to talk first about complementary and supplementary angles. Complementary angles are two angles, it has to be two angles, that add up to 90 degrees. So, and I drew two examples for you. They could just be, side by side. I'll use the pen in yellow here. Could be side by side because 30 plus 60 adds up to 90. So those angles we could call complementary. We could also make them adjacent right next to each other, sharing a side, like this diagram, and add them up to 90 degrees in the diagram. Those two angles are also complementary. Let's move on to supplementary in light blue. Supplementary angles are angles that add up to 180 degrees. And you're going to have to learn these terms. So when you see the word supplementary, you're going to think, okay, two angles, they add up to 180. So again, I drew them two different ways for you. So here are two supplementary angles separated. One's 120, 160, 120 plus 60 adds up to 180. So those two angles are supplementary. Or you can draw yourself a straight line like this angle here. And that's called a linear pair, which we're going to learn about in a bit. And say, and look at the two angles, and they do add up to 180 degrees. Adjacent angles, which I was just referring to a little bit ago, are two angles that are right next to each other, and they have the same vertex. Here's the vertex, okay? So they have no common interior points. So they share a side, and they're just right next to each other. It's like adjacent houses. So your neighbor's house is adjacent to your house. It's right next to. A linear pair are two adjacent angles, so right next to each other. They share a side. But they're very special. They have to make a line. They have to be supplementary. Oh, I just gave you the answer to the next problem. Is a linear pair supplementary? Yes. Okay. So vertical angles. Two non-adjacent angles that are formed by intersecting lines. So you can draw two intersecting lines, and these angles, they are not adjacent, so they're opposite each other. Those are vertical angles, and here's your second pair. And I'm going to show those two angles are vertical angles, and that actually means they're congruent. Those two angles are congruent, and those two angles are congruent. That's going to become useful. So let's see if we can't practice. All right, so complementary angles. Complementary angles are angles that add up to 90 degrees. So I look on my diagram, well, 52 plus 38. So let's see if we can name those two angles. And this brings back what we learned the other day about how to name angles with three letters. So complementary angles, the angle ABD, and angle BDC, because 52 plus 38 adds up to 90. Now you could name angle ABD, you could call that angle DBA, same thing. All right, in a different color, supplementary angles. Supplementary angles add up to 180. So maybe you might first think, well, here, those two angles, but 128 plus 38 doesn't add up to 180. However, 52 and 128 add up to 180. So let's see if we can name those. Angle ABD and angle, I'm just going to call that one EDB. And you could have called it BDE, same thing. All right, let me erase what I drew on my diagram here and go to a different color. And let's do adjacent angles. Adjacent angles are right next to each other. They've got to share a side. I think the only pair is right here. So let's name them. Angle BDC and angle, I'm going to call this one BDE. Okay, so if you need to look at that some more, you can rewind it and listen to it again. I'm going to go ahead and move on so this video is short. Okay, find the measures of complements and supplements. Sometimes it'll usually be written in a sentence. I drew the diagram for you for this one, but the next one I want you to draw the diagram. Given that angle 1 is a complement of angle 2. Okay, that tells you automatically those two angles add up to 90 degrees. And they tell you that the measure of angle 2 is 57 degrees. What's the measure of angle 1? Well, I mean, here's the measure of angle 1. There's angle 1, there's angle 2. All right? Together they've got to add up to 90. So I drew myself a diagram. And then based on how I wrote this, I'm going to write my equation. X plus 57 adds up to 90. And then you would just solve that by subtracting 57 from both sides. So X is 33. So the measure of angle 1, which is what they're asking, find measure of angle 1. The measure of angle 1 is 33 degrees. Now that's my answer, so I'm going to circle it. Boom. Supplement. Given that angle 3 is a supplement of angle 4, those two angles have to add up to 180 degrees. So here's angle 4 and here's angle 3. So I'm just going to say, all right, x plus 41, that's got to add up to 180 degrees. Subtract 41 from both sides. And if you want to stop and do that yourself, please feel free to do so. So I've got x is 139. So the measure of angle 3 is 139 degrees. That's my answer, so I will circle it. Moving on. All right, I'm going to have you guys try this. Press pause. Do exactly what I did in the previous two examples. And if you have trouble, go back and look what I did. And then press continue. I'm about to show you the answers. So here we go. Here are the answers. So I drew myself the diagrams. And then I wrote myself the equations, and you might have an x instead of measure of angle 1. It doesn't matter. It's all good. As long as you got, for 2a, the measure of angle 2 is 17 degrees, you did well. And for b, the measure of angle 3 is 143 degrees, and you circled it, you are doing well. You are right on track. All right, so here we've got a word problem, okay? And a lot of people have trouble with word problems. So this is a basketball pole. It's no different than the other ones. They've just made this angle into a basketball pole. Are basketball poles tilted like that? Okay. The basketball pole forms a pair of supplementary angles with the ground. Find the measure of BCA and the measure of DCA. All right. So I know that by looking at the diagram, this is a straight line, which means those two angles are supplementary. They add up to 180 degrees. So I'm going to write my equation first. 3x plus 8 plus 4x minus 3 equals 180 degrees. Now I'm going to solve it. I'm going to add the two x's. I've got 3x's and 4x for a total of 7 x's. 8 minus 3 is a positive 5. And that's a two-step equation. I'm going to have you solve that. Press pause. See what you get. You should have gotten x is 25. Now that we've got that, we read the problem again. Shoot, they didn't ask for x. We are not done. We have to find the measure of angle BCA. Now BCA, they told us is 3x, and x is 25. 3x plus 8. So we break out our calculator, Desmos, whatever, 83 degrees. So that's 3 times 25 plus 8. And the other one that they're asking us to find is DCA. DCA, we are told in the diagram, is 4 times x minus 3. X is 25. Break out the calculator, do 4 times 25, which we already know is 100. Subtract 3 and we get 97. Now again, if you figure out that 83 and you want to subtract that from 180 to get the 97, you are gold. That's perfectly fine. It's all good. Do what you got to do. Okay. So I'm going to teach you now about linear. Well, okay, yeah. So we're going to identify linear pairs. Now, a linear pair, if you look back, and I'm just going to flip back to show you where we learned about that in the diagram. Here, a linear pair, two adjacent angles that make a line with outside rays. So they have to be right next to each other, right? Adjacent. So if we look for those here, the only two, I mean, I see 1 and 2. Ooh, 1 and 2. And what about 2 and 3? I know you guys are thinking that. If you were in class, you'd be yelling it out for me, and I'd be writing it on the board. So linear pairs are 1 and 2, and 2 and 3. Now, vertical angles, remember, they are created by intersecting lines. So if I look at these intersecting lines, I've got vertical angles at 1 and 3. But then the other way, 2 and, well, that's not a vertical angle because 4 and 5, those are different angles. So I only have one pair of vertical angles there. So now what I'm going to have you guys do is look at this diagram, and every diagram is going to be different. I want you to identify the linear pairs and the vertical angles. Press pause. Okay, here we go. There are no linear pairs. That's because a linear pair means 2. It means 2 angles that have to add up to 180. So we can't, 180 degrees is going to, in this diagram, is going to give us 3 angles. So we don't write all 3 of those. The linear pair is 2. But the vertical angles, we got a whole bunch. We've got 2 and 5. We've got 1 and 4. And we've got 3 and 6. All right. So here, this is a little bit more difficult. So 2 angles form a linear pair. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. Okay, well, they told us the measure of this smaller angle is x degrees. Well, the other one is 4 times as big. How do we write, using algebra, something is 4 times as big? Well, that's 4x degrees, right? So if I want to put degrees, I've got to put it around the whole quantity. So there we go. So, okay, so x plus 4x adds up to 180 degrees. So that's 5 x's equals 180. I hope you can't hear my dog chewing on the bone. He's right at my feet, and he will not leave. Benji, it's distracting. Go. I'm throwing it. Maybe he'll stay over there. Okay, so that should have given you some time to find the value for x. He's right back. Is 36. All right, so now we have to, we're not done. We got to find the measure of each angle. Well, the measure of this angle, the first one, I'm just going to call it angle 1 and angle 2. Measure of angle 1 is clearly just x, or 36 degrees. But the measure of angle 2 is 4 times x. And again, you could just do 180 minus 36, and you get the same thing. So there we go. There are answers. Boom. Moving on. Okay, so concept summary. So interpreting a diagram, there are some things that you can conclude by just looking at a diagram, and there are others that you cannot. For example, here are some things that you can conclude. You can look at this diagram up here and you can say all those points are coplanar. They're all on the same plane. And it looks like A, B, and C are on the same line, so they're collinear, and we can assume that. We can also assume that this line AC and this ray BD and this ray BE all intersect at point B, right here. We can assume that. We can also assume that if angles look adjacent, they are. If a line looks like a line, it is. And it looks like point E is right in the middle of this angle DBC, we can assume it is. Okay, but you cannot conclude, for example, that, do you see how this segment AB and this segment BC look the same length? We can't assume that they are unless someone tells us that B is the midpoint or gives us those little marks to say that those segments are the same length. Okay, let me erase those because they didn't tell us that. We can't assume that the measure of these two angles here, are the same, even though they look the same. We can't assume that. We can't assume that they're right angles. We have to be told that the lines are perpendicular. That would tell us that we've got a right angle. Or sometimes they just say the measure of this angle is 90 degrees, and then you know it's 90 degrees. And the last thing we're going to look at today, and you might want to take a little break and press pause, are classifying polygons. Now you can go over what those are, but convex and concave are very important. So if you can draw a line on the edge and extend it, and it doesn't touch any part of that figure, it's convex. If it cuts through, it's concave. So I'm almost at the end of this video. Here's what equilateral, equiangular, and regular look like. And this is just a quick little shot. But you need to know these prefixes. This is something you need to know before you hit geometry. And here are the answers for convex versus concave. Peace out.